Hello everyone, welcome to Aptitude Jab. This set from CAT 2017 Slot 1 DILR says that 4 cars need to travel from Akala to Bakala. Two routes are available, one via Mamur and the other via Nanur. The roads from A to M and from N to B are both short and narrow. In each case, one car takes 6 minutes to cover the distance, and each additional car increases the travel time per car by 3 minutes because of congestion. For example, if only two cars drive from A to M, each car takes 9 minutes. On the road from A to N, one car takes 20 minutes, and each additional car increases the travel time per car by 1 minute. On the road from M to B, one car takes 20 minutes and each additional car increases the travel time per car by zero point 0.9 minutes. The police department orders each car to take a particular route in such a manner that it is not possible for any car to reduce its travel time by not following the order while the other cars are following the order. So let us try to map this route based question and solve the set. So we are given that there are two cities A and B. They are connected via two routes, one via M and another via N. So cars can travel AMB or ANB. It is given that from A to M and from N to B, each car takes 6 minutes. A to M 6 minutes, N to B 6 minutes. However, there is an additional car, it takes 3 more minutes. So we will write plus 3 plus 3. Then it further says that from A to N, one car takes 20 minutes and M to B also 20 minutes. So A to N 20 minutes and M to B is also 20 minutes. But here we are given 1 minute for A to N. So this is plus 1 and M to B it is plus 0.9. So essentially what it means is, like, if let us say there are 3 cars traveling on this route. So suppose A and B, there are 3 cars in A and B. So what will happen in this case is, one car takes normal time is 26 minutes, 6 plus 20. However, there are two additional cars and one additional car is 3 and 0.9, 3.9. So 3.9 into 2, that will give us 33.8 minutes. Okay, so this is how we need to make the calculations. Now let us formulate the different scenarios and then figure out what should be the answer to this question. So we will have 4 scenarios, in fact 5 scenarios. So we have A and B, A and B, 0, 4, 1, 3, 2, 2, 3, 1 and 4, 0. We could easily reject these cases 0, 4 and 4, 0 by using common logical reasoning that if there are all cars in one route, that will be highly congested and each one will try to, a person will try to break the rule to come to this route, right? But let us see it mathematically as well. Now A and B and A and B each take 26 minutes, both routes take 26 minutes. Now for extra car in A and B, the time increases by 3.9 minutes and in A and B, the time increases by 4 minutes. So if A and B has no car, so 0 time, so this is no car. Now here it is 26 minutes and 26 minutes. Now A and B, it increases by 3.9 minutes. So that will be 29.9. Then we have 33.8 and 37.7 minutes. And here the time increases by 4 minutes. So 26, 30, 34 and 38. Now the question says that some cars have to travel on A and B and police department has to give this order to to order some cars to travel in the route A and B, so that if cars break a rule, they do not have the incentive to reduce the time. Okay. Now suppose, as I said, that these are obviously the extreme options. So if there, let us say four cars are here, so obviously someone will try to break the rule, because if it is four and this car breaks the rule, so it will become three cars here and one car here. So definitely they will be at advantage. Earlier this car was taking 38 minutes, now it will just take 26 minutes. Okay, so this will be a violation of a rule, and of course these will also save time. So this is not possible. Now suppose there are three cars. So this car, like traveling at 34 minutes, will have uh, the incentive to break the rule, because if it breaks the rule it can travel in 29.9 minutes, so obviously it will break the rule. Now if you look at this scenario, if this car going at 30 breaks the rule, okay, so that means it will take more time, 33.8 minutes, so it will not break the rule. Okay, it will not break the rule because it will take more time. So the answer should be 2 2. Now let us say if this situation is happening 1 and 3 here. Now in this scenario what will happen is they will not break the rule because they are taking less time, but this car can break the rule because it is uh, it is traveling at 33.8, and if it moves to this scenario, it is cars are taking 33.8 minutes, but if they break the rule they will be able to travel in just 30 minutes. So this scenario also is not possible because the cars will tend to break the rule. So logically also one could have answered that the route is going to be 2 2. Mathematically also we have proven that the routes have to be 2 in each of the routes. So A and B, there are two cars that should go by that. If all the cars follow the police car order, what is the difference in travel time between the car that takes the route A and B and the car that takes the route AMB? So AMB and ANB, we see the times are 29.9 and 30 minutes. So the difference is zero point 0.1 minutes. Next question. Now we are given additional information. We are given that a new one-way route is built from M to N. Each car now has three possible routes to travel from A to B: AMB, ANB, and AMNB. So let us draw these routes first and then look at the conditions and try to solve the question. So we have M and N at this place, A and B. Now this was AMB was 6 minutes, and this was also 6 minutes, plus 3 plus 3. Then this was 20 and 20, and MB was zero point 0.9, and AN was plus 1 minute. These were the initial conditions. Now if a car takes this route A, M, N, B, if a car travels in this route, we know these distances are already known to us. Now we should see that what is the additional time in this route. It says that M to N, that car takes 7 minutes. So the travel time is 7 minutes, and each additional car increases by 1 minute. Okay, so that is the route diagram. Now let us write the time with no conjunction. So there are, if the car takes A and B, it will take 26 minutes. Okay. If a car takes A and B without congestion, it will be 26 minutes. If a car takes A, M, and B, it will take 6 plus 7 plus 6, that is 19 minutes. But there will be, it will meet some cars in the route AM and NB, somewhere it will meet, so that time will increase. Now we will make a table that how many cars will travel in A and B, how many cars will travel in A and B, and how many cars will travel in A, M, N, B. Now in the previous scenario also, we saw that extremes we need to avoid, because if we take the extreme cases, there will be congestion in one of the routes, and hence the cars will take extra time. So in this case, since there are four cars, the optimum conditions would be 1, 1, 2. Now, which route one car, which route two cars? So we will have three scenarios. So we will have 1, 1, 2, 1, 2, 1, and 2, 1, 1. So let us put these scenarios: 1, 1, 2, 1, 2, 1, and the third scenario as 2, 1, 1. So three scenarios taken. Now, if a car is traveling, now these are the routes: AM, AN, AM, NB. That will be the time taken. So we will have to find out in each scenario how much time, extra time, will a car take. Now suppose a car is going from AMB. So in this route AM, it will encounter two extra cars because two cars are going in this thing. So normal time is 26. Okay. So case 1, I'm writing the times here. So AM, the normal time is 26, and in the route AM it will encounter two cars. Okay, AM part it will encounter two cars, extra cars. So time taken will be 32. Then in the part MB it is all alone because no car is traveling from MB. Okay, so it will just take 26 plus 6, 32 minutes. Now let us imagine the car traveling from A and B. So normal route time is 26 minutes. In the route AN, it does not have anything common. Okay, so no time, extra time here. In the route NB, it encounters two cars that are traveling by this route. So two cars, it means 6 minutes extra. So this car will also take 32 minutes. Okay. Now the third case is third AMNB. The normal time is 19 minutes. When it is going from A to M, when the car is going from A to M, it meets one car over here. So 3 minutes extra for this. Okay. And so there actually it will be 6 minutes. So AM, there are three cars, two cars this plus one car. So three cars, that means two extra cars. So 6 minutes. Now from the route MN, here there are three cars, there are two cars. These two cars are traveling in M to N. So two cars will increase the time by 2 minutes. And then we have uh, two cars means one extra. That means time will increase by 1 minute. MN, there are two cars traveling, one extra, and hence increase of 1 minute. Similarly, in NB, there are two plus one, three cars. So since there are three cars, that means there are two extra cars and will take 6 more minutes. So total time taken will be 32 minutes for this also. So this is one case, 32, 32, 32. Now let's take the second scenario in which we have one car in this, two cars in this, and one car in this route. So when we are talking from A and B, so the car is taking 26 minutes. Now in the part AM, it will encounter one more car. So it will take 3 more minutes. Okay. There is one more car in AM. And MB, there is no other car. Okay. So it will not experience any more car here. So it will take 29 minutes. Now the car traveling at A and B is taking 26 minutes. Now from A to N, it will encounter one more car. Okay. So it will take zero point 0.9 minutes more. And from N to B, it will encounter one car from this route and one car. So there are three cars in the route A and B. So it will encounter, it will take 6 more minutes. That will become 32.9 minutes. Now talking about the third car that is in this route, the fourth car that is going in this AM and B route. So normal time is 19 plus AM. It will have one more car because one car is going in this route. So AM will add 3 minutes to it. It will just add 3 because only one extra car is there. Okay. Now MN, it is the only car. So it will not have any extra time in this route. Okay, so MN, it is the only car. Now in NB, there are there are two extra cars. Okay, so NB, it is one car is this and two cars are these in the NB part. So there it will have additional time of 6 minutes. So that means it will take a total of 28 minutes. Okay, now the third scenario, if we take two cars in the AMB route, okay, if two cars in the AMB route, so 26 is the normal time. Now in the AM part, we have 1, 2 and 3 cars, 2 extra cars. So 6 minutes added over here. Okay. And in the next phase, MB, it has AM, it has 2 more cars, and MB part, it will have 1 more car. That is, the 2 cars are traveling in this route. So they will take 1 more minute. So that will make it, sorry, this will be zero point 0.9, and the previous case it should have been 1 here. So it would be 33 in this case, and MB, one more car, so total 32.9 minutes. Now the car from A and B, 26 minutes normal time. AN, it is not experiencing any other car. Okay, so no extra time for this. Now from NB, it will have one extra car. Okay, so obviously it will take 3 more minutes. So total 29 minutes in this case. And AM and B, the normal time is 19 minutes. In the route AM, it is experiencing 2 more cars. So 6 minutes here. In the part MN, it is not experiencing any car. And in NB, it has 1 more car. So it will take 3 more minutes here. So a total of 28 minutes. So these are the 3 scenarios that we will get. Now it is saying that how many cars should be in A, M and B. Now let's take this scenario. That is, the all cars are taking 32, 32, 32 minutes. And the car does not, if one car follows the order. Okay, so two of the cars will save the time, but one car will lose on the time. Okay, so obviously they will follow the order. If 29, 33 and 28, so obviously two cars will try to, like, they are taking 29, 33 and 28 minutes, so the cars will try to break the order. So if it breaks the order, it will have an advantage that it will save time. Okay, and hence this case is not possible. So if it is traveling at 33 minutes, it will try to break the order. Okay, and it can go to any of the routes. If it is 28 minutes, so 28, 29 and 32.9 minutes, so this car is going to, like, if this is two cars in this route A and B, so they will try to break the route, so take another route so that they save on the time. So the most optimum time we see is win-win for all, that is 32 minutes. So we should have two cars on the route A, M and B. So in such kind of questions, we need to have a win-win situation. Like we did in the previous case, it should be win-win for all. So here the win-win situation is 32, 32, 32, all taking the same time. So all will try to follow the order. But if there is different time, let us say 33 minutes. So this car has the incentive to break the order because it will save on the time. And in this scenario, this card will try to break the order. So it should be a win-win situation for all routes. So the answer is two cars. Now the question is, if all cars follow the police order, what is the minimum travel time from A to B? Okay, so obviously we see that the minimum travel time in this scenario will be 32 minutes. In other cases, the travel time increases beyond this. So the answer is 32 minutes. So this was the solution to the set and the answers to the questions.